In this video, I would like to explain about the sampling distribution of a sample mean x bar. Let us assume that we have a population of mean mu and standard deviation sigma. And first, we are trying to pick a sample of size n, a random sample of size n from this population. It will have a mean and let that be x1 bar. Again, we are picking a simple random sample of size n from this population. Its mean be x2 bar. A third set of simple random samples is picked from this population with the same size n, and let its mean be x3 bar. Like this, we can repeat this process many times, and then we can find x1 bar, x2 bar, x3 bar, etc. to be the mean of this sample sizes. So since these samples varies, these x1 bar, x2 bar, x3 bar will be a variable quantity. So that set will again form a distribution, and the set involving this x1 bar, x2 bar, x3 bar, etc., which forms a new distribution, is called a sampling distribution of mean x bar. And this new distribution of mean x bar, mu, and the standard deviation will be sigma by square root of n, and this distribution will be normal. This is explained by a theorem called Central Limit Theorem. And in the Central Limit Theorem, like in our previous case, we have a population with the mean mu, standard deviation sigma. A simple random sample of size n is drawn from this population, and if n is large, then the sampling distribution of the sample mean x bar will be approximately normal with mean mu, standard deviation sigma by square root of n. Means, regardless of the shape of the population, it need not be a normal distribution. The population can be from any distribution, but if the sample size n is large, then the sampling distribution of the mean x bar will follow a normal distribution with the same mean as that of the population, but the standard deviation varies, which is sigma by square root of n. What if a sampling distribution is obtained from a population where that population is originally normal with mean mu, standard deviation sigma? If the population itself is normal, then regardless of the size, we need not worry about the size. The sampling distribution will automatically be normal with mean mu, standard deviation sigma by square root of n. Let's see an example here. An unknown distribution has a mean 45 and a standard deviation 8. A sample of size 30 is drawn from this population. We are asked to find the probability that the sample mean is between 42 and 50. That is, it is given that the distribution of x is from unknown, it is unknown distribution, but it has a mean 45 and standard deviation 8. We are picking a sample of size 30. And if we are interested in finding the probability between 42 and 50, that means we are trying to find the area between 42 and 50 for the sampling distribution x bar, which has the same mean 45. The standard deviation is 8 by square root of 30. So it is a sampling distribution with a mean 45, standard deviation 8 divided by square root of n, where n is 30 here. Since we are interested in finding the probability between 42 and 50 for this x bar, we can make use of our graphing calculator normal CDF key, where we have the lower bound as 42, upper bound is 50, and the mean mu is 45. The standard deviation is 8 divided by square root of 30. So when we apply that, we get the answer as 0.9797. So that's the answer for this question. In our second example too, it talks about a recent study on the furry blog. It says the mean age of tablet users is 34 years. The standard deviation is 15 and a sample size is 100. If we are trying to find the 95th percentile for the sample mean, 95th percentile means 95% of people are less than this value. So 95, we are trying to find the value on the x-axis such that the area to the left of it is 95%. The area to the left of it is 95%. So this shaded region here is 95%. We are trying to find what this area is, this point is, the point on the x-axis. So we can make use of the inverse norm key. Inverse norm, area to the left, the mean, the corresponding standard deviation. But in this case, it is not just sigma. It will be sigma divided by square root of n. So it is 15 divided by square root of 100 because it is for sample distribution, not for the original distribution. So it is 15 divided by square root of 100, which will be 36.5. So in this video, we talked about the sampling distribution of a sample mean x bar. We explained how to get the area between two values for a sampling distribution. And also we learned about the case when the area to the left is given. We are trying to find the point where the area to the left is known to us by using the inverse norm key from our calculator. Hope this explanation was clear. Thank you for watching this video.